Bismillah ar-Rahman ar-Rahim. Today we're going to talk about buoyancy and stability. This is group number 8. For our group, my name is Nooraldeen, Hanie, Abdul-Aziz, Abdulmaksoud, Aldeeb, matric number 209586.
And my name is Ahmad bin Al-Faheem, and my metric number is 210811.
My name is Al-Faheem bin Jamaludin, and my metric number is 212974.
My name is Putra bin Zulkiflee, and my matrix number is 210016.
My name is Ibrahim bin Abd-Majid, and my metric number is 213030.
My name is Anselm Lim Hai Seng with matrix number 213126.
So for the table of contents, we have 7 topics we're going to talk about today, and each topic has subtopics under it. For our introduction, as we know, there's an old story about a king that asked a goldsmith to make him a golden crown and to check, and then he asked a Greek mathematician, which is Archimedes, to confirm the purity of that golden crown. So Archimedes got into his bathtub to think, how am I going to solve this king's problem, and etc. During which he noticed that as his body sank into the water, the level of water had gone up, and the more his body sank in, the more the water had been displaced. From these observations, he realized that it's common for a person to feel lighter and weigh less in a liquid than he does in air. And those observations also told him that there is some force in the water that exerts an upward force on whatever body is immersed in it. So this force, the buoyant force, is mainly because of the pressure that increases as an object sinks deeper in a fluid, which in this case is water. And the force from the pressure exerted in the downward direction on the top of the object is less than the force from pressure exerted in the upward direction on the bottom of the object. There is a simple analogy called ball on the floor, which is used to make the understanding of stability and instability much simpler. So we have 3 scenarios. In scenario A, it is stable since any small disturbance, whether it's right, left, or wherever, it's going to return, the ball is going to return to its original position due to gravity. And then we have B, which is neutrally stable, because if disturbances occur, the ball would stay put at its new location. So it basically has no tendency to move back to like its original location, nor does it continue to move away. And the third scenario is a situation, as you can see, on top of a hill, where it's at rest, but any disturbance can cause the ball to roll off, which means it's unstable. So any object experiences 2 opposing vertical forces when floating. So one force is the weight, its own weight, which is downwards, and the second force is the buoyant force, which is upwards. Weight acts at the center of gravity, and the buoyant force acts at the center of buoyancy. So if W and BF, which is weight and buoyancy force, are both equal, they would be collinear, and the body will be at rest. So as you guys can see in the second picture, there is something called point M, which is known as the metacenter, which is the intersection of the axis of the body and the line of action of the buoyant force. So basically, if M is over G, then BF and W, which is the 2 forces, they will produce a restoring moment, which causes the body to return to its original position. Therefore, it's stable. But if M is under G, the body becomes, however, unstable, and this causes not a restoring moment, a overturning moment made by both of the forces. So if M coincides with G, the body is said to be just stable, neutrally stable, which simply means it's in a critical position.
Now I will continue with the literature finding with our first subtopic. So for background study, the importance concept of buoyancy force, which is the force that pushes against the weight of a submerged or floating object, is the power that maintains the buoyancy of ships and other objects. The weight of the fluid that the object displaces is equal to the buoyancy force. The pressure differences between the objects that are denser than the fluid will sink, while those are less dense will float. The volume and shape of the object also affect the buoyancy force. The buoyancy force of a larger object will be greater than of a smaller object. The density of the fluid, the shape of the object, and the fluid's temperature can also affect buoyancy.
So as you guys can see, for renewable energy, we have 4 types of sources that harness this wave energy using devices, and they also convert the kinetic energy to waves into electricity. We have wave and tidal, which they basically work in the same way, and the floating wind turbines and the ocean thermal energy. Thus, this tells us that buoyancy plays a very important role in the development and implementation of wave, tidal, floating, and wind energy systems, as it allows for the designs and construction of devices that can efficiently convert that energy of ocean motions into electricity.
Okay, talking about climate change and pollution, the phenomenon of buoyancy can unfortunately also lead to pollution in various forms. For example, buoyant plastics and other debris can travel distances and threaten wildlife and their habitats. And additionally, oil spills and leaks from ships and offshore drilling equipment can have a detrimental impact on the environment. And lastly, the principle of buoyancy is not only limited to physical objects, but it also plays a role in the release of gases that contribute to climate change. These gases, such as methane and carbon dioxide, can be released from oceans and seas due to buoyancy. This occurs when these gases, which are less dense than the surrounding water, rise to the surface as these gases are released into the atmosphere. They can contribute to the warming of the planet and the alteration of the Earth's climate.
Okay, now I will explain about the conceptual of the system. Moving on to the next slide. All right. So basically, this picture is all about the buoyancy-based hydroelectric power generation systems. So first of all, hydroelectric power generation systems in dams use the weight of water to turn a turbine and generate electricity. Impoundment system is the most common type of hydroelectric power generation systems in dam. And buoyancy power generation systems use the buoyancy force of the water to generate electricity rather than the weight of the water. And buoyancy power generation systems are typically more energy efficient than the traditional hydroelectric power generation system. And buoyancy power generation systems do not require the construction of large dams. Right. Now I will explain, I will illustrate how a buoyancy power generation system works. All right. So first of all, 2 or more horizontal rotating shafts submerged in water, position one above the other, and then sprocket wheels mounted on the shafts that engage with a continuous chain loop, and then continue with a vertical sprocket wheel above the chain loop that supports a series of identical buckets, an air pump position underneath the buckets that generate an upward moving stream of air, a gearing system that transfers the rotation torque to a generator which produces electricity, and then continue with airfill containers submerged in a tank of water or other heavy liquid that provide the buoyancy force to rotate the generator shaft, and then 1 or more conventional commercially available air pumps that provide a continuous powerful rotation of the generator shaft. And it works by the air pump generates an upward moving stream of air which collects in the rising buckets and displaces the water filling the bucket. And this results in a powerful upward thrust caused by the buoyancy of the bucket, which causes the bucket to move upwards, rotating the horizontal shaft. And then another water-filled bucket is brought into position above the air pump. The rotation torque is transferred to a generator which produces electricity, and it's a continuous process depending on the flow of water.
So moving on to the 3D model system, it works exactly the same as what Zulkiflee has presented. So in the front view, it consists of chain, bucket, turning gear, air pump, and big container. And on the top view, as you can see, the component that has been circled with a red circle is the turning gear of the mechanism, which helps in turning the chain in a circular motion while bringing up the bucket from the bottom to upper. Next slide. Okay, this is the mechanism on the left, and on this right, it will be the side view, and the one that has been circled is the air pump, which is one of the important part is the system because the air pump provides air into the mechanism, which helps in filling the bucket that is in the downward direction with air. Next. This is the close up for the mechanism. On the left is the upper, and on the right is bottom.
First, before we can calculate the boiling force and the power generate, we first need to find the volume of the bucket. Since the bucket is trapezoid, so we use the trapezoid formula, which is A plus B times H times L per 2. So when we use the formula, we get the volume is 0.0858875 meter, calculating the boiling force. So we use the boiling force formula, which is FB per negative PGV, which is P is volume, G is the acceleration due to gravity, P is the fluid density. For G and P, we use the constant value. So we got the boiling force is 858.357 Newton. Next is to calculate the power generated. To calculate the power produced by the hydroelectric, we first need to determine the boiling force. The expression for power is work per time, and since the expression for work is force time displacement, the expression for power can be written as force time displacement per time. Since the expression for velocity is displacement per time, the expression for power can be written once more as force time velocity. So since we cannot find the velocity in this paper, we have to make the assumption for the velocity and take the boiling point we got before. The assumption for velocity is 9.2 meter per second. So we got power is 7,897.05 watt. Next slide is the result interpretation. From the result, we can see that in order to generate more electricity, force and velocity must be increased. This is because for power is directly related to the product of force and velocity. This is a principle of physics well understood in various fields. From the result, we can also see that buoyant-based relative power generation is a promising process for generating electricity. This utilizes the water inherent buoyant force as a dependable and consistent source of energy. Next slide is the advantage of buoyant-based hydroelectricity power generation. There are three. First is can generate electricity at a relative constant rate. Second is can be used in a wide variety of applications. And next is use the renewable energy.
Okay, in the hydropower, the environment and society, the use of natural resources such as oil, gas, and coal can have negative environmental impacts. The demand for electricity is increasing due to population growth. So the solution to this issue include reducing energy consumption through conservation and producing electricity in an environmentally friendly manner. Hydroelectric power generation, such as buoyancy-based system, can be a viable alternative as it offers many benefits, including providing domestic water supplies, regulating water quality, preventing flooding, and enhancing the environment downstream. By building new power plants or upgrading existing one can be done with minimal impact on the environment if proper consideration is given to environmental factors. So finding a balance between humans' needs and preserving the environment requires trade-off and compromise and should be approached from ecological, economic, technological, and society perspective.
Okay, so for project improvement and recommendation, as previously noted, buoyancy should not be limited to situations that involving solids in liquid. So natural convection and multi-phase flows are at least two significant applications that areas can be directly related to the buoyancy effects. So a buoyancy hydropower installation should made in accordance with the present invention where the wave and sea current energy collectors powering in air compressors, or compressed air pipes carrying compressed air to submerged storage chambers, expansion pipes up through which the air is released, including inducing the water flow through a turbine chamber, and the turbine powered by the induced flow to produce energy. It is preferred that the wave energy collectors and compressors are mounted to be platformed at sea level, that is supported by a vertical tower that extend below the surface of the ocean. So alternatively, a buoyancy hydropower storage installation consists of at least one compressor that pumps the air into storage, at least one pipe that runs from the storage to the floor of an upright rod tube submerged in the water, and at least one turbine that uses the water flowing through the rod tubes flow to produce electricity. A different embodiment of the emergence provides a method of generating electricity by anchoring the device of the sea floor and set the device including energy collectors that for wave. A different embodiment that collects the wave or the sea currents of the power compressors, compressed air pipes that transport compressed air to immersed storage chambers, Expansion the pipes ups with the release inducing the flow of the water through the turbine chamber, and the turbine powered by the cost flow to produce the power. A method of generating electricity, as you can see.
So as Aidid and Ray and Ibrahim mentioned, the most common used systems is dam, is the impoundment system, which uses the weight of the water to turn a turbine. These installations are designed to harness the energy of natural convection, where heated fluids rise and cold fluids sink, etc., just to generate electricity. So basically, different ways improve energy collection, such as using as Aidid said, variable amounts of ballast in buoyancy tanks and mounting wave energy collectors on platforms. In conclusion, buoyancy power generation systems are an alternative to the traditional hydroelectric power generation systems, which use the buoyancy force as a rather than weight to generate electricity. These systems are more energy efficient, and as Ibrahim said, they use renewable energy, so they are very good for our environment. That's all from us. I hope you didn't take much of your time, and thank you very much.